Well, thanks, Jenny, David, and welcome everyone. Good morning. First off, we would just like to thank TNC and the Southern Fire Exchange for inviting us to be a part of this webinar series. As Jenny mentioned, we're going to discuss how we leverage and enhance land fire products to update the Southern Wildfire Risk Assessment. And I always like to tell everyone that we really believe, land fire got us 85% of where we needed to be and for our project, and we just had to do the remaining 10 to 15% to complete our project. So we're very thankful for the land fire project and the products that they produce. As Jenny mentioned, or as David mentioned, just please submit your questions anytime. We'll try to answer those as we go through the presentation today. Try to keep it as informal as possible. So looking at today's agenda, we're going to be talking about the Southern Wildfire Risk Assessment Update Project. We're going to give you a little primer on that so you'll have an appreciation for why and where we're calibrating fuels across the South. For those of you new to fuels calibration, we're going to cover a few land fire fuel calibration basics and then move right into the Southern Wildfire Risk Assessment Update Project and then talk about our process, specifically the workshops and some of the tools that we produced, and then talk about some of the key issues and improvements we made as part of our project. And then at the very end, we'll tell you where you can access the data, and from there we'll move forward. There we go. So if you take a look at this title slide for the Southern Wildfire Update Project, this fire in the background is a fire that we had in 2011, about 85 miles west of Dallas. It's called the PK complex. It's burning an ash juniper vegetation type. That ash juniper is approximately about 40 feet tall, and the flame lengths kind of coming off of that are probably 90 to 100 feet tall, kind of barreling down over this home. But fortunately, this story ends on a positive note because it did have some defensible space in and around the home. Firefighters were able to move in, remove any flammable material around the house. If you look in the corner of the home there, you can see a barbecue pit, maybe a gas grill, and some firewood that was stacked up around back. They were able to move in and save this home. But other homes on this fire weren't as fortunate. And this is kind of a trend across Texas, across the South, with the increase of a wildland-urban interface, fuel changes or land use changes and climate changes. We've seen some significant fire behavior over the last several years. And this has really left people asking, well, where's the risk? Am I at risk? What can I do proactively to mitigate my risk? And this is a great question, and this is the heart of what we're trying to do with our wildfire risk assessment, is identify where the risk is. The image in the background was the Bastrop complex, another fire that we also had in 2011. Kind of the blue outline there is the perimeter of that fire, and if you kind of look in the middle, more than 1,500 homes burned in this area. So one of the key products that we produce to try to help answer this question is a product that we call, or a metric that we call WUI Risk Index. And it's really just a combination of flame length and the wildland-urban interface. So if you look at the top left there, you're looking at flame length. The map's categorized in different flame length categories, from blue being kind of a lower flame length to red being higher flame lengths. And then if you look on the right, there's a data product that we produced from the LandScan data set that was really developed by Oak Ridge National Laboratories of a prediction of where people are living on the landscape. And we kind of converted where people were living to housing density to kind of correspond to the true definition of wildland-urban interface. But through a GIS process, we combine these two data sets and then come out with a metric that we call WUI Risk Index. And really this is just, measures the level of impact. So if you have low flame lengths and low housing density on a scale of -1 to -9, -1 kind of being the minimal impact, those are kind of your gray areas. And on the other end of the spectrum, if you have high flame lengths surrounded where a bunch of homes are, that's a -9 impact. I don't know what happened there, David, but the attendees list, yeah, thank you. So anyway, this is one of our main metrics that we use in the Southern Wildfire Risk Assessment. And although we weren't able to do too much prior to the Bastrop fire, we want to be able to identify these areas across the South, be proactive in what we're doing, get out there and preach mitigation and try to take care of things in advance. So we take a look at this map. This is really a combination of where people are living next to high flame links. Again, the red being places where you'd have high flame links and high population densities. The yellow areas, you know, moderate density population, maybe moderate flame links, and again, the gray and blue areas are kind of on the lower end of the spectrum. But as state agencies, you know, federal agencies, we can use this map to prioritize where we want to do mitigation across the South. You know, essentially, if you have $100 in a tank of gas, where are you going to go out and make a difference? And I'm going to turn it over to Buck here now to introduce kind of the broader risk framework that we're using.
Thanks, Curt. Pleasure to be here, folks, and happy that we get to share with you what we've done with LANDFIRE and the enhancements we've made, all with, you know, the focus on defining risk. I think as a starting point, we really need to define what risk is. I think most of us that have been involved in wildfire risk projects have seen a myriad of terms from hazard risk or whatever, and I think the quantitative risk framework we use helps to define that. You know, the simple definition of risk is the possibility of loss or harm occurring. And that's what we're really interested in, is finding out that loss or harm. So what are the fundamental elements? And then we'll tie this into how LANDFIRE data and fuels data and Canopy data really fits into it. If you look at the risk framework that's been evolved over the last 10 years, led primarily by the work of Joe Scott with his colleagues Dave Cockett and Matt Thompson at the Fire Lab. Joe, of course, works with Pyrologic, his own consulting company. There's really, you know, it's hazard and vulnerability is really what we care about. On the hazard side, of course, we have probability or the frequency of a fire occurring. We have, if a fire occurs, the level of intensity. And that really gives us our hazard, you know, what's that landscape? We often see that term hazard used instead of risk, and it's really not correct. It really describes the sort of landscape conditions around and the fire behavior that can be expected. Vulnerability is really the exposure, really the location of those values at risk and where they exist and how exposed they are. And their susceptibility. What is the impact of those? I think you saw in the previous slide that Curt showed, we can delineate through a process called response functions, the level of risk. And that can be tailored to local understanding and local conditions. So when you throw those both together, you smash hazard and vulnerability together, we get a measure of risk. So how does this apply in the Southern Wildfire Risk Assessment? Well, the first thing we wanted to do was define the different components. So here this just shows you the different layers that were created or utilized. We didn't create all the layers. In that, you can see our focus was very much on defining WUI risk. That was the priority, led down by the Southern Group of State Foresters and the fire chiefs. You know, on the probability side, we can use some existing products, some of those from the original assessment, and burn probability from the Fire Lab and the FPA. We chose not to use that. We chose to use focus mostly on intensity. So it would be conditional outputs if a fire does occur. This is where the LANDFIRE data and our updated fuels we did really fits in. It is the basis or foundation of creating the fire behavior outputs. The metric we used to define our level of intensity was flame length, highlighted in red there. On the exposure side, we looked at several things. Where people are living, which is really housing density across the board. The WUI is really with the urban areas extracted, and that was our primary focus. We also looked at something called community protection zones and even some operational metrics such as dozer operability ratings versus using fire lines. But if we take our flame length and WUI, that allowed us to develop this measure of susceptibility, which is our WUI Risk Index. Now this framework's, you know, evolved over the last 10 years. We've applied it in multiple projects. The West-wide risk assessment, state of Colorado, California, state of Texas, one of the first places. And now we've extended that across the South. Of course, our focus was very much on scale down and focusing on this WUI risk. So what were the objectives of the, to tie this all back to LANDFIRE and the fundamental fuels and Canopy data? Well, our first step was really to take that latest, greatest LANDFIRE data, the 2010 data product, and really review that directly with the states and their representatives. And then adjust that, or as we say, calibrate it, to reflect the fire conditions that are observed and expected by the states. One of the things we wanted to make sure, because fire behavior is so critical to deriving the risk outputs, was that fire behavior and the fuels, underlying fuels input data, really reflected what folks were seeing out there in the ground. And that's something we've simply learned. And the best way to do that was to really engage those people, and Curt's going to review that entire process with it, of the 13 southern states. And that started by working with the state representatives and the locals, but also extending out to our federal partners, of course, which have a lot of that expertise as well. Once we have that updated fuels, then we want to create the updated fire behavior and the values at risk, or as commonly referred to, fire effects outputs, for this update of the 2010 Southern Risk Assessment. We coined it 2010 simply because the LANDFIRE source data was 2010. Although some of the values at risk, such as the wildland WUI interface, was actually up to 2012. You could expect that it's an iterative process because our validation or rating criteria is really the expected and observed fire behavior that the Southern fire chiefs and their staff experience out there. Number 1 and 2 is very iterative, in that we would update the fuels based on their review of the area. We generate the fire behavior, review that in detail, generate some statistics on it, and that continue to iterate until we got the calibration of those fuels, obtaining the fire behavior that they expected. Once we did that, we would generate the risk outputs, and we needed a delivery mechanism. So the delivery mechanism was the Southern Group of State Foresters Wildfire Risk Portal, coined SouthWRAP. And that gives the ability for us to share that with other fire planners, operational folks, and the public. Last but also importantly is to provide training and support to the states and their Fed reps, since this is wall-to-wall coverage in the South, for using SouthWRAP, the web application, and those results. So the GIS data was also provided to each of the agencies, in addition to being loaded up on SouthWRAP. So lastly, before I pass it back to Curt, just let you know who the participants were. Well, this is all driven by the Southern Group of State Foresters and their fire chiefs for the individual states. And that was our primary client, if you will, in this regard. The Southern Wildfire Risk Steering Committee, that's been ongoing for about 10 years now, kind of helped to direct the sponsor of the project. Curt and I acted as the sort of project managers and the technical leads from the technical team. As Curt mentioned, the LANDFIRE team was very supportive and played a key role, particularly early on, in providing the source data to us and giving us information about their methods and their crosswalks. I had a really good support team from various agencies working with me underneath. And then, of course, fundamental to the process was the ownership taken on by the Southern Group of State Foresters, the individual states, those forestry agencies, and their staff. Just absolutely fundamental response and ownership by them, and that's what made the success of the project. Of course, federal representatives and even local reps were really key to the process as well. And Curt's going to walk through this process now. I'll pass it back to him and give us a feeling for the level of calibration that we undertook.
Yeah, so just kind of moving into the calibration part of the presentation. One of our main objectives was just to review the LANDFIRE 2010 outputs, identify any potential concerns, and then provide guidance for calibrating the source data to properly reflect Southern fuel and fire behavior conditions. And then secondarily, as with any products, user input always equals better products in the future. And we just wanted to thank LANDFIRE for the contribution that they made. And in return, we wanted to provide feedback to the program for future enhancements. So these were our two main objectives in the fuel calibration process. So moving to the fuel calibration basics. In our project, we calibrated both surface fuels and canopy fuels. Although the fire behavior between these two are linked, the calibration process is pretty different or distinct for each of these, and we'll kind of review some of the key terms and definitions for calibration. So when we're talking about calibrating surface fuels, we're really talking about the fire behavior fuel models. These are just really simplify the fuel bed characteristics for prediction of surface fire behavior. Joe Scott and Robert Bergen have published a nice document kind of describing these in details if you want additional references of what these are. But traditionally there was 13 of these, And with the publication of this document, they introduced 40 more fuel models. And then for canopy fire calibration, we're really talking about adjusting, for our project anyway, canopy base height and canopy bulk density. So canopy base height is really that average height from the ground to a forest stand's canopy bottom. And it's really a fact, the main factor in this is determining canopy fire initiation. So depending on the relationship between the surface fire and the canopy base height, you may or may not have a canopy fire for a particular stand. And then canopy bulk density is a factor in determining canopy fire type and rate of spread. So once it does transition to a canopy fire, it can either be a passive crown fire or an active crown fire. Passive is just individual tree or group torching, and then an active crown fire is where it moves up into the canopy and then makes a little run and then maybe drop back down until the surface fire can catch up, and then it'll make, get heated up again and then make another run. So really looking at 3 different fire types: surface fire, passive canopy fire, and then active canopy fire. We'll kind of explain these as we go through the project. Just talking about the, sorry. I'm not sure what happened there, David, but it looks like some slides might have gotten deleted or something happened there. It didn't come all the way through. So sorry for the blank presentation here. So let me just try to describe this for you. I know you're not able to see this in full. So, LANDFIRE basically uses a rule-based approach for assigning and calibrating fuels. And what you're not seeing on the screen there is really the rule set that we use. It's really existing vegetation type plus existing vegetation range plus existing vegetation cover, and then the biophysical setting, which is really just your historical vegetation communities on the landscape, equals a fire behavior fuel model. The nice thing about this approach is, and traditionally when you do remote sensing or classification, you can try to map that directly using remote sensing techniques. With fuels, it's really hard to see what's underneath the forest stand and be able to map those fuels accurately. So this rule-based, or what we call an inferential approach, really allows you to create rules, redefine the rules, to crosswalk that basically to a fuel model. The main advantage of this process is if you don't agree with the rule, you have the option to really change these as part of your project. So just going to the next slide here. Again, not everything is showing, but if we go up to northwest Louisiana and look at map zone 37, if I wanted to create a rule for our pine plantations up in the northwest part of Louisiana, the first input is the existing vegetation type, which is a pine plantation. The existing vegetation cover, is 60 to 100% for this instance. And the height is between 15 and 30 meters, if I remember correctly. So what that's really telling you is you got a pine plantation, somewhat mature, it's closed in nature, meaning that it's going to suppress out all that vegetation underneath. So a typical plantation in northwest Louisiana is not going to have much of an understory after the stand closes in. And you could expect that to be a timber litter fuel model, especially like what we call maybe a TL6, just a typical timber litter fuel model. Not a lot of fire behavior associated with that as far as the surface fire is concerned. But if you were to move down into southwest Louisiana, you move that same plantation down south, you run into a flammable shrub zone. In these pictures, we're looking at a yopon and a gallberry species that are found in the understory. And the rules could be exactly the same, but we would change the biophysical setting for this rule, just saying that if you're down south in that coastal shrub zone, you're likely to run into these evergreen waxy leaf species that are quite volatile and contribute to the fire behavior significantly. So we want a rule that says that the biophysical setting has been changed. And again, the rule sets they're missing above. But in addition to the key pieces that I've mentioned so far, we asked Landfire, well, what about disturbances over time? You know, how do they fit into this process? And Landfire maps disturbances, and we found this one of the most beneficial data sets because disturbances is really broken down by type, severity, and time since disturbance. You know, it's basically 54 combinations there that you'd have a choice from. So if you have a pine plantation, for example, it can have up to 54 disturbance types, and you can make a different rule based on the disturbance. So as you can see, you know, this becomes quite complex in the number of choices that you have for modifying and calibrating these fuels. One of the things we found very beneficial was using the Landfire Total Fuel Change tool. This is the ArcGIS extension that you can load in ArcGIS to help you manage your rule sets and your data sets. So if you look down there at the bottom, the rule sets, when they come out of the box from Landfire, are kind of organized by map zone. So each map zone has a set of rule sets that can be applied in combination with the data sets to derive rules. Is what this Landfire Total Fuel Change tool is really allows you to get under the hood, be able to look at these. You could simply click on the fuel model or an existing rule, click on the fuel model, change that really simply if you didn't agree with the rule. You can even get a little more advanced. You can add rules, you can edit rules, you can delete rules, and copy rules maybe from other projects that people have defined. So a very robust application that they developed, and we found this quite useful. Again, the existing vegetation type that we're looking here is a managed tree plantation, southeast conifer and hardwood plantation group, and this one has 3 rules really associated with that. Again, as we mentioned, you know, the TE3 that you see there in the middle exhibits, you know, moderate to extreme fire behavior, whereas the TL6 is a little less. So as what I see missing here is I don't feel like there's enough TU3 in this existing rule sets to kind of accommodate that southwest Louisiana area that I showed you where the Yopons were located. So just to look at the difference in fire behavior, this tool also has a tool where you can compare fire behavior, rate of spread, flame length over a range of percent dead moisture and percent live moisture. If you look at the fire behavior graph below, the TU3 area, or coded as 163, that's located in southwest Louisiana, you know, under a 6-mile-and-under wind, is exhibiting 10-foot flame lengths, whereas the TL6 up in the northwest of Louisiana only exhibits 3-foot flame lengths. We really worked with our fire behavior specialists to kind of confirm these are good outputs or typical outputs for those fuel models in those areas and those vegetation types. So you really need to work with your fire behavior specialist to really define and select these fuel models. So, you know, looking at the difference here, you know, 10-foot versus 3-foot, I really want to add a rule that really pick up that area in southwest Louisiana that I would be concerned about. So using this tool, I selected the add rule. It's the 4th row there now. You can see there's 4 rules. And these were if you kind of look at the range of cover, range of height, the biophysical setting, or the BPS, and the fuel model 40. I had kind of graphics of those in previous slides. But these are the combination of inputs that you have, and you can tweak to create a new rule. So in this example, I felt like if you know the canopy covers 40 to 100% tree cover, and the range of height is anywhere from 10 meters to 50 meters, and it's located in that coastal shrub zone that I mentioned earlier, which is coded as that 1,444. I wanted to select a TU3 fuel model. One of the other things this tool provides, it breaks down how many acres are located on the landscape within your project area based on the rule that you just added, and then what percent that represents. So I went ahead, added the rule. I can see that I have 6.22% on the landscape. That seems a little low to me, just kind of knowing the area, knowing what's down there. So one of the things you can do with the tool is also output a new data set. So here I've looked at the input data set, basically the default Landfire before modification, and then after modification, after I added that new rule. So you can see there's a little bit of change there. A little bit of area went from TL6 to TU3. I really masked out all the other fuels just so we could compare these two and be able to visualize this for the presentation. But as I mentioned earlier, I didn't really feel like that seemed right acreage-wise. And sometimes in going through these process, additional issues can become highlighted for you. I did a little more investigation, and what I thought was pine plantation, based on my experience, in the Landfire project, it was actually mapped as another EVT type. In this instance, if you look at the pink area, it was mapped as a West Gulf Coastal Plain wet longleaf pine savanna and flatwoods. Now, this is probably the historical vegetation community in this area, but over time, as different timber industries have moved in, all this has been converted to pine plantation, basically the areas that you see in pink. I know this from driving through the area. We're looking at the border between Texas and Louisiana, and I can say that the area in southeast Texas, all that's definitely pine plantation for that area. And that was a concern, at first to the states. And we can kind of confirm what I've told you. One of the data sets Landfire produces is a disturbance data set. So as what I brought up here is the mechanical remove loading. These are basically harvesting operations that happen from 2000 to 2010. So within that red circle, you can see, quite a bit of that landscape has been harvested just in the last 10 years. And if you were to go back, 30 or 40 years, you probably could see that most of that area was harvested and converted probably to pine plantation. So I'm not really going to address this issue right now. We'll talk about how that was fixed a little later on in our project. But I just wanted to give you a few basics on how the calibration process works, some of the tools that are at your disposal, and then kind of how we use those. So let's just kind of summarize the data sets that were required for our project. If you look over on the right, you can look at the fire behavior outputs, flame length, rate of spread, fire line intensity, and then fire intensity scale. These are the outputs that we needed for our project. And we generated these for 4 percentile weather categories: low, moderate, high, and extreme. So to be able to calculate these fire behavior outputs, you have to have inputs in the modeling process. And up top there in the middle section, you can look at the Fire Behavior Fuel Models 40. That's what we selected for this project. You also need canopy cover, slope, aspect, and elevation. With these data sets, you can calculate surface fire behavior. And then optionally, and actually required as part of our project, we needed the canopy fuel characteristics, which include canopy height, canopy base height, and canopy bulk density. These are the data sets that we use to calculate the canopy fire potential, and they're also the ones that we needed to calibrate if we weren't receiving the expected canopy fire height for a particular area. And then finally, if we look at the fuel calibration inputs, we needed existing vegetation type, existing vegetation cover, height, the biophysical setting. Again, that's the historical vegetation community on the landscape, the disturbance data set. And since the fuel rule sets were mapped or assigned by map zone, we used the mapping zones as a wild card. And that's just another data set that you can use in the process as part of your rule set if you wanted to. And then also another data set is canopy guide. And that just is really a guide to tell the modeling process whether you think canopy fire behavior is likely or not for a particular EVT combination. And then finally, we'll talk about this a little later as evergreen forest cover. This was one of the key data sets that we produced as part of the project that we found useful in the calibration process. So just to kind of review again the scope of our project, they told us they wanted 10 states reviewed and calibrated. That equated to 16 map zones, and then you combined all that to data. That's basically 150,000 rule sets that we were supposed to review. And they said, oh, by the way, you need to do this in 5 months, in time for the Southern Group of State Foresters annual meeting that was in New Orleans in May. And they said, can that be done? And you're like, yeah, sure, no problem. So we went back to the drawing board, figured out how we could really pull this off in 5 months. And when you go back and look at it, we decided we should actually have web workshops instead of scheduling on-site workshops. that was the only way to really meet with these groups, the times that we needed to meet with them over the duration for this project. We didn't really have time for on-site workshops. So we decided to go with web workshops. We did a prototype for Arkansas to really define, see how the web workshops worked, look at the process for doing these, and define our method, and define our methods. Once we got that down, that kind of took from November to January 2014. And then once we had the process down, then we scheduled the other 4 groups. If you look at there, Group 1 is Louisiana, Mississippi, Alabama. 2 is Kentucky and Tennessee. And Group 3 is Georgia and South Carolina. And then Group 4 is North Carolina and Virginia. And we decided to kind of move from west to east as we scheduled and worked with these workshops, just to make sure that any seam lines that may have been a result of our calibration process, that those can be smoothed out as we moved from west to east. And in addition to that, we had already calibrated Oklahoma and Texas, so we wanted to make sure the results lined up, across state boundaries. So for each of these groups, we went through a process with each one, multiple workshops, but really, the first thing is just to work with the states, identify those areas of high concern, based on their experience in the field, areas that they felt exhibited, extreme fire behavior that really gave them problems from a suppression standpoint. And then we identified, likely solutions or calibrations that needed to happen for those landscapes. And then we went away and processed those changes and created fire behavior outputs for those areas. And then we came back in workshop 3 and 4, reviewed the results with them, made sure they met expectations. If they didn't, it's kind of an iterative process. We went back and modified everything. And then finally, the end goal was to produce the fire behavior outputs so that we could use those as inputs to update the Southern Wildfire Risk Assessment. So that maybe pause there for a minute, see if Buck has anything to add or if there's any questions before we move forward.
Any questions, folks? It's a detailed process, as you can see, with a lot of different players, but we were able to knock it off. Any feedback or questions on the process we use for the workshops?
Yeah, please submit those anytime, and we'll continue to move forward.
Sounds good.
Yeah. So looking at the scope of the project, we knew we didn't have time to teach everyone how to be GIS experts, how to load the change fuel tool that LANDFIRE developed, and how to use that process. So as our technical team, we really decided to handle that in the background and not really expose that to the participants. But we wanted to deliver the data to them so they could interrogate that, review that, and provide us their comments. So we came up with a suite of tools that could really be delivered in tools that they were familiar with, Excel, Microsoft Access, and then we developed a LANDFIRE web viewer so they could really interrogate the results. And I just wanted to review quickly some of the tools that we developed for the participants to review fuels in their area. So the first thing was the LANDFIRE viewer web application, which really allowed us to look at the suite of data sets, all the inputs into the fuel model calibration process. In this example here, we're in Tennessee, right in central Tennessee, and Tennessee, had identified a couple of seam line issues in the default LANDFIRE data that they wanted to fix or take care of, so that there wasn't a hard line transition as you move from map zone 53 to map zone 48. There's really 2 issues here. We'll tackle number 1 first. Is they started investigating. There's an identify tool that they could use. So they identified that dark blue area in map zone 53, and it kind of went to light blue fuel model there, basically from a TL8 to a TL9 across map zones. They just wanted to see if there was a difference in some of the input data sets or what was going on there. So using the identify tool, they could identify that this was the Allegheny, Cumberland, dry oak forest, and woodland type. And they clicked in map zone 48 and then found out that it was the same, existing vegetation type, and the covers were the same, the heights were the same. And come to find out, it was probably just a difference since these field models are assigned by map zone originally. That maybe a different person attended map zone 53 than the person that attended map zone 48, or maybe it was the same person and they just slept in between workshops. So that was maybe one difference that you might see across seam lines. In this instance, it didn't really matter too much. The fire behavior between TL8 and TL9 is not that significant. And then if we move to the second area that they wanted to calibrate, is basically a difference in pasture and hayland. And here we have a difference in the input data set. Sometimes the difference between the seam lines may be due to the inputs being mapped inconsistently. Here in map zone 53, you have a very high herbaceous cover, and then in map zone 48, the herbaceous cover drops off pretty dramatically, to 10 to 19%. And that's doesn't really represent reality, and is a concern to the folks there in Tennessee of how to best fix these issues and represent them. So one of the another tool that we really provided to them was be able to filter all these rule sets. Again, there's 150,000 of these. It kind of become overwhelming, and each rule set for each map zone could be a little different. They could be the same. So one of the tools that we provided were then to be able to filter these rule sets down. So here we're just comparing the pasture hayland EVT type in map zone 48 and map zone 53, and they can confirm that the rule sets here were exactly the same. So it wasn't a difference in opinion, between one area and the other. There's really a difference in the underlying existing vegetation cover that really drove the difference there for that particular area. So these are an example of some of the tools that the participants used to kind of interrogate the data, look at areas to see if they agreed with it or not. As part of the process, we developed a database for the participants to use to really document their concerns. We really tried to keep it at a very high level, not drilling down at the rule set level, but just keeping more general feedback kind of at the EVT level. So the workshop participants could select a particular EVT and then fill out all the questions that we kind of provided to guide discussion for the calibration process. And this is kind of what we used as documentation, as we made changes behind the scenes for the project. So the key issues and solutions, really, there was a lot that we looked at, but I think if we just take a look at the top three, this represented probably 90% of the changes that we made for this project. And the number one issue was that, pine plantations are significantly undermapped. In addition to being mapped as other pine or mixed forest types, as in the example that we saw in Louisiana earlier, they were sometimes mapped as hardwood EVT types. And the main issue here is there wasn't really a way to extract these evergreen areas that were kind of embedded in the hardwood EVTs. And we'll go through the solution and how we fix that here in a moment. And then the second issue is when we ran the fire behavior, the feedback that we received is canopy fire is really underrepresented for these dense, unthinned pine, conifer EVT types. And then three, we needed to eliminate or reduce arbitrary seam lines between map zones or state boundaries. Sometimes politically, it's hard to say why things increased or decreased as you cross, these arbitrary lines. So that was a big point of emphasis, is to reduce those seam lines across state or mapping zone boundaries. So now I'm just going to walk through some of the solutions that we came up with to fix the first two. Again, we worked with Arkansas as part of the pilot project. We identified several EVTs or mixed EVTs that had dense pine stands located in them, and we wanted to be able to extract those. So we did a little remote sensing with Landsat imagery. We pulled Landsat imagery from 2010 and basically classified that into evergreen forest cover. Was it greater than 75% cover, 50 to 75%, or less than 50%, evergreen cover. So if I go back one slide, look there where the blue circle is, you can see a pretty dense plantation in this area. This particular area is near just north and east of Mena, Arkansas, near the Ouachita National Forest. I think maybe some plantations that were planted some time ago. And as we go forward, you can actually see that red area actually extract those dense pine plantations out and then the orange and yellow areas are kind of less dense evergreen forest types. Anyway, we completed this process for the entire South, trying to map this evergreen forest cover. And really what we're trying to do is get to, conifer forest cover and the density of that. As the feedback that we got from the states is that they were really concerned about these areas, not only from a surface fuel perspective, but also from a canopy fire potential perspective as well. So once we had our evergreen forest cover mapped, we went through a process where we took the existing vegetation type from LANDFIRE, combined that with the evergreen forest cover, really to derive conifer forest type groups. So this is, the focus here on creating these groups was really to focus on, one, just to simplify the number of EVTs that we were looking at in our project. Just because you have a difference in EVT doesn't really mean that's a difference in fire behavior. So we wanted to create these logical groups and really simplify the number of vegetation types that we were looking at for our project. So we were really looking at things like needle type. Did it have small scale-like needles like eastern red cedar or ash juniper? Or did it have, medium to long needles, maybe like some of the southern yellow pines or Virginia pine? We also, in our groups that we created, we wanted to look at tree growth, form, and, branching structure of those types of trees. And then also the EVT mapping accuracy, just because you had an EVT out there that you might have wanted to create a separate group for. It may or may not have been mapped as accurate as we would have liked. And depending on that accuracy, we decided to, to either include it with another group or make it its own group. But one of the main advantages of going through this process is really we're able to extract those evergreen types out of those hardwood areas and create their own group for those. And then that allowed us to really change the fuel model just for the just for those areas within those hardwood EVTs, and not have to change the entire EVT. So that's kind of the process that we went through for our improvement to define these conifer forest type groups. Another thing that we were told that was a concern is these flammable evergreen shrubs. So we worked with the states, using a combination of data sets, but really the biophysical setting, the BPS data set. We worked with them to identify these evergreen shrub zones where, the yaupons and the wax myrtle, swamp tie-tie, gallberry, palmetto would exist. Those areas are identified in green. And then we worked with Virginia and Tennessee. They said they have some evergreen shrubs up in those areas as well when they're combined with, pine types that really, cause some issues for them up there. So we created a, mountain zone, which really included the mountain laurel and some rhododendron species. So within these areas, if pine was to intersect, these types of shrub zones, you could predict that, it may be likely that there may be waxy leaf flammable evergreen shrubs in the understories within these areas. Finally got the rule sets to show up. Thank goodness. So here's our modified process for calibrating the fuels. The areas in green represent changes that we made to the original LANDFIRE calibration process. But if you just look here, we took the existing vegetation type plus the evergreen forest cover and then created these conifer forest type groups. And then, we also wanted to insert the evergreen forest range cover because dense pine plantations may have additional fuel loading. There may be a different fuel model that you want to call there. And then we left the brown areas were the original pieces of the LANDFIRE fuel model calibration process. So you have existing vegetation cover, existing vegetation height. And then instead of looking at all the potential biophysical setting combinations on the landscape, we really simplified those in those 2 or 3 groups that we looked at earlier. And of course, we used the wild card for the map zones. So using this combination, we were able to assign fire behavior fuel models across the landscape. So if we go back to this area in Louisiana that we were looking at before, we can look at before modification. There's a lot of TL6 in this area, which is kind of on the lower end of the spectrum fire behavior-wise. And then after modification, you can see that there's quite a bit of area converted to this TU3 for southeast Texas and southwest Louisiana. And this is what was confirmed, by the state fire chiefs and their fire behavior specialists that they thought this was a little more representative on the right for this area. So we applied this, south-wide. This is the surface fuels before calibration. And then I'm going to flip to and show you after calibration. We may flip back and forth just a couple of times, but within this red area, we're really, some of the major seam line issues that we addressed as part of our project. So if I advance forward, you can really see how that was smoothed out across these map zones and improved. If you look in the orange fuel model, which was the a custom fuel model that we came up with, it's kind of fire behavior-wise sits kind of in between the TL6 and the TU3. There's these orange, light orange colors. You see that primarily in the north part of Zone 37, Zone 46, and 54. Based on feedback, the teams really felt, if a pine plantation existed, hadn't been prescribed burn in a while, that the fuel loading was really increasing in these areas and represented a little more of a problem. So we created a custom fuel model, basically called it a 9 ppl for 9 pine plantation, really without the flammable undergreen understory. And that's what you see in the orange areas across the south. And then if I flip back to the original one more time, if we look at that coastal zone, and also there in Zone 57 in spots, you can see that a lot more TU3 has been picked up along the coast, especially where those flammable shrubs are known to exist. And this addressed most of the surface fuels issues that the states wanted. And we feel like that we made some pretty good improvements on adjusting that using the evergreen canopy cover combined with the EVTs that LANDFIRE had produced. This slide's a little busy, and canopy fuel calibration is a little more complex process than the surface fuels calibration. But basically, is what we did was we had the participants define their expected or observed fire type for each combination of conifer forest type group, disturbance, and fuel model, kind of based on the following criteria. So if you look at this, the top matrix here, example 1, we're looking at a southern yellow pine group, no disturbance, has that 9 ppl custom fuel model that I mentioned. And then we go down here and look. We got canopy height here on the left. So we kind of relate this to canopy base height. As height increases, you would expect the canopy base height to increase. And across the top here, we have the flammable canopy cover, 25 to 49%, 50 to 74%, and 75 to 100%. For each weather category, low, moderate, high, and extreme. So what this first graph is telling us is that they expect passive crown fire, which is represented as the orange color and tagged as P, with a pretty dense, flammable canopy cover, pretty dense conifer stand. And as that conifer stand increases in canopy bulk density, they expect some passive and active crowning over there. So for each of these rule sets, we had them define that, and we use this information to calibrate the canopy base height and canopy bulk density accordingly. Example 2, there may be another rule set where they say, well, the fuel loading was really reduced in this area through prescribed burning or other mechanical treatments. The surface fuel model is less extreme, and we're not really anticipating any canopy fire in these areas that have been prescribed burn, and that's what the second example shows there. So for these areas, if canopy fire did exist, we removed it, and we didn't calibrate these areas to support canopy fire for these types of scenarios. This is just an example of 2, but we did this for each combination, kind of a fuel model, the conifer forest type groups, and then based on disturbance as well. So if we kind of take a look at the results in Arkansas, you can look at before calibration. This was kind of what you'd see. Again, the orange area on the map is representing passive canopy fire. Doesn't really show any active canopy fire, kind of in the default fuels data set from LANDFIRE and the weather parameters that we used for our project for extreme weather. But after calibration, you do pick up quite a bit more active canopy fire as well as passive canopy fire, especially in that north or central to north part of Arkansas. So you see the little blue box there in central Arkansas there to the left. We'll zoom in and just take a look at that to see what that looks like as far as imagery is concerned. So you do have a little bit of passive crowning there on the south end on the default parameters from LANDFIRE and our weather. And then after calibration, especially some of these dense stands and some of these stands in the steep topography. What the feedback that we got from the Arkansas team is, yeah, they really expect some passive crowning and maybe a little bit of active crowning in this area. And that's what the calibration results really gave us. So just to kind of summarize the calibration project for Arkansas, we were able to pick up 3 million acres that weren't passive or active canopy fire before, which really represented a significant difference on the landscape. And the Arkansas team really felt like that was a better representation of what they experienced based on their observed or expected conditions. We felt like we made some good improvements as far as calibrating the canopy fire. We applied this concept across the entire South. Here we're looking at extreme weather fire type that was calculated for the South, so you can kind of get a picture of what's going on there. Again, if you look at that shrub zone across the coastal area, you see a little bit more of active canopy fire. Again, that's because of the increase in the surface fuel model, the TU3, and the pine plantations. It was a little easier for those areas to transition to an active canopy fire. Whereas, through the central part of the study area, you see a little bit of passive canopy fire there where those plantations were located. But overall, a pretty big improvement in canopy fire. So this is one of our main outputs as far as the fire behavior is concerned. Now what I'm going to do is just step in and review a couple of our main outputs from the Southern Wildfire Risk Assessment, and then just sum up with where you can find some of this data. So here's our final surface fuels map. You notice Florida looks a little different. They had done their own fuels mapping and calibration about a year or two prior to our project, and they were really comfortable with using what they had, and they mapped theirs to the original 13 fire behavior fuel models instead of the 40. So that's really why you see a color difference or a seam line there along Florida. But if you look at the rest of the South, we think the fuel model map looks pretty good, and not too many seam lines as you go across the study area. We were really satisfied with the product that we produced here. One of the new products that we produced, we really worked with Joe Scott, a new metric that they have produced, fire behavior output called fire intensity. So similar to the Richter scale for earthquakes, it's a logarithmic scale, and the order of magnitude in fire intensity is tenfold between each class, and it's a 5-class system. So as you go from class 1 to class 2, the fire intensity is tenfold, and from 2 to 3, and so on and so forth. The class 5, there's really, you don't want to put any suppression resources on that. You just want to go to evacuation mode. Suppression is not going to really do you any good by the time you reach an intensity level of 5, whereas an intensity level of 1, you can use direct suppression, minimal equipment to extinguish that fire. Just to kind of give you an idea of the difference between each of these classes. Another data set that we mentioned before is where people live. This is how it shows housing density across the South. And we really use this layer as an input to derive our WUI data set through some advanced GIS modeling process. And then finally, this brings us back to where we kind of began today, the WUI Risk Index, and being able to identify those areas where we want to support mitigation, be proactive in what we're doing. And if we have $100 in a tank of gas, where are we going to go? And all of these data sets can be found at southernwildfirerisk.com. So if you've seen something that you like today, you're able to go and download the data here. We also, with a professional viewer, you're able to generate reports, really advanced report. I think it's a 50 to 70 page report that's generated for a project area that you define, really summarizing these results. So some advanced capabilities that you can access in this website. Really encourage you to go take a look. You can look at some of these data sets in detail for areas that you know. And with that, I'll just turn it back over to Jeannie and David, and we'll take a few questions.
Thanks, Curt. It's Jeannie back with you. Thanks, everybody, for sticking around. We've got a full hour here of information. And I'll put up our contact information now. We'll let this sit up here as we do the Q&A. This is the TNC LANDFIRE team. You can reach any of us with our direct email addresses, as you can see there. David's address left, Curt's right, and Buck's at the bottom. So we'll let this one sit up up here, and if you want to stick around and ask any questions, we'll get going. Terry Jenkins has one up right now, so I'm going to throw this to you guys and see who wants to take it over. Thanks again, everybody, for sitting in on this final webinar series.
Thanks, Jeannie. David Buckley here. Terry Jenkins has asked, we still have a huge hole over the Okefenokee National Wildfire Refuge, the water issue. History has shown that the area will burn. Yeah, we know that significantly. And so we have some more work to do there. We'd like to work with you to address this. Have a look at the products, Terry, on the Southern Wildfire Risk. One of the things we really tried to accommodate was that issue. Not saying we've got it nailed by any means, but have a look. If you look at some of the products, the fire intensity scale, some of the fire behavior outputs, I think we did start to address that because of the history of it burning. And so that might be a good starting point for you. You will note, though, of course, as that dips into North Florida there, because Florida chose to use their fuel models and the definition of what they did, the fire behavior generated by their fuel models is a little different than the fire behavior that was used in Georgia as in the rest of the South. So that may be something you'd want to look at, but that might be a good starting point. Curt, any feedback on that?
No, I think that's a pretty good description there, Buck. And if it is, maybe if it was mapped as water to begin with, we didn't really convert any water pixels, so that may be an issue that we could go back and look at and say, it was mapped as water, but it's really, got grass in there with it and can burn. And I'm not that familiar with this area, so I would need to go and take a look. The Okefenokee, I guess, National Forest versus the National Wildlife Refuge and the vegetation differences there. I don't know if we're talking about the swamp or coastal areas.
Right, I was thinking swamp, of course. So Terry, hopefully that, I see from your note that that helped. But we'd love to chat with you and talk with you in the future. Any other questions, folks? Totally open to any of those.
But we're waiting for a few more questions to come in. I didn't know if you had anything you wanted to add here at the end.
Yeah, maybe just add a couple things while we're waiting to see if there's other questions in. It is important to know that when Curt showed us the fuels data set for the entire South, and Florida looks different because they focused on the 13 fuel models instead of the 40 or the combined 40 and 13. But it's important to note that Texas and Oklahoma previously did updates using LANDFIRE as a source, but updated Canopy and fuels mapping. And you'll see the seam lines match really well with Arkansas and Louisiana as they move across, and that's because they utilize the same definition of fuels and custom fuels. There's a few custom fuels in there. And so the blend is really nice across the seam lines. So it wasn't just Florida that brought its own fuels to the table, Texas and Oklahoma. So our project was really focused on those other states. We did do an update to Oklahoma to capture those Canopy data sets. So that we could better represent where those pine plantations and dense canopy stands are. David's asked, any plans to update these layers in the future as disturbances and populations change? That's really a question for the Southern Group of State Foresters and the Southern Risk Assessment. The original Southern Risk Assessment using a crosswalk of fuels was done in 2005 is when it was delivered, but most of the work in 2003, it took us until 2013-14 to get the funding so that we could do this update. My expectation is you're probably waiting another 3 or 4 years to do that. Although with some of the data sets that are readily available, such as LandScan, the dead population count data set from Oak Ridge National Lab, that's ideal for updating WUI and therefore making urban growth changes into your fuel models, even at a local level. So that's something I think that folks could look into in the future. But right now, as I understand, there is no maintenance plan in place for the Southern update. Our hope, of course, on the fuels mapping is we don't really want to do this calibration. We fully endorse the LANDFIRE program. And our main intent was to provide this detailed local information back to LANDFIRE so that the next version of LANDFIRE can continue to accommodate it. And therefore, inherently, the LANDFIRE program would provide the updated fuels, and we wouldn't have to ever do this again. And we can focus just on the risk stuff. Terry's also asked, any chance of development of a rule for organic soil effects? Well, I'll kind of throw that over to you, Curt, on your side of the fence.
Yeah, definitely any data sets that you think could help you calibrate the fuels you can add in. You know, by default, Landfire and their Landfire change tool, they have a wild card in there so that you could add organic soil as another layer and develop rules based on organic soil. So the answer to your question is yes. I know Florida, you know, use this quite a bit in their fuels mapping project in Florida due to the organic soils. So yes, that can definitely be accommodated.
One other point I'd like to add, and it's about access to the data. You know, one of the things that we want to do is make sure that people are fully aware of this data and can access it to use it. Within the SouthWRAP portal, the professional viewer, once you register for it, allows you to export data, define a mitigation project area, and export the data. You know, we'll create an ArcMap document all zipped up with all the individual raster layers, put it on an FTP site, and send you an email with a link so you can download that data, and away you go. We fully appreciate that a lot of the analysis that folks like yourself will do needs to occur outside of the delivery mechanism, the SouthWRAP application. It is important to note, though, that there is a restriction on the size of the project areas. I believe it's, Curt, do you remember, is it 10 million acres?
I think that sounds right, but I'd have to look to make sure.
So the point is that you can only export an area that you can define up to 10 million acres. If you want anything larger, you should put a request into the individual state agency. They own the data and have the data. And for example, if you want a statewide data or data for national forest that cross boundaries or something like that, state boundaries, you can put that request in and get it from them. If it's less than 10 million acres, you can simply define your project area with the professional viewer application and then download it. The export typically takes about 5 to 10 minutes, and you'll get an email and you can download it and away you go. So there is a size limitation. We don't want people trying to download the entire South and ground the application to a halt. But it is a great mechanism for distributing the data and getting it out to folks.